Assalamu alaikum. Well, children, in the previous video, we discussed the trigonometric ratios of complementary angles. We derived those 6 relations we got, relations of trigonometric ratios of complementary angles. You must have by now gone through those solutions, revised those to make those things clearly understood, because today we have to apply those relations in our exercise number 3. I shall write those relations here so that we can apply. We have the first relation, sine of 90 minus theta is equal to cos theta. The first relation. In that relation that we derived yesterday, it was sine 90 minus a equal to cos a. A I have replaced here by theta. Then second relation was cos of 90 minus theta is equal to sine theta. Another, tan 90 minus theta is equal to cot theta. Then cot 90 minus theta is equal to tan theta. Sec 90 minus theta is equal to cosec theta. And the last one, cosec 90 minus theta is equal to sec theta. These are the 6 relations. We'll be applying these today in the questions. Look at question number 1. There are 4 parts of this question. Let us begin with part number 1. We are asked to evaluate. Now, what does evaluate mean? Find the value of. The value of these parts we have to find. And the first part is sine 18 degrees divided by cos 72 degrees. This is the first part. Look at the angles involved this time. When we were doing questions in the previous exercise, we would always find angles written there, those specific angles. Either it would be 30 degree, 45 degree, 60 degree, or sometimes it would be 0 or 90 also. But now the angles are not among those specific angles. We, in this exercise, will come across angles of any measure. Now particularly we'll be using acute angles. But any acute angle can be involved. Like here we have 18 degrees, 72 degrees. It can be any acute angle. And whenever you have such questions where those specific angles are not involved, you will have to use these relations. Relations of complementary angles to solve them. Remember what we did in case of specific angles? We used the values from the table. Now, we do not know the value of sine 18. We do not know the value of cos 72. So the value cannot be put. We have to solve this, therefore, by using trigonometric ratios of complementary angles. Now, how we do this? Look at 2 things in this. The 2 angles which are given here, 18 and 72, if you add them, you will get 90. Means they are complementary angles. This is one reference to the fact that you have to use complementary angle relation. That the sum of the angles is 90. 18 plus 72 is 90. As you will proceed, we will solve the other parts of this. You will find there also the angles involved will be complementary angles. Their sum will be 90. Second indication to the fact here is the 2 trigonometric ratios involved. Those are also complementary trigonometric ratios. Sine and cosine are complementary trigonometric ratios. Sine is related to cos here. Cos is related to sine. These are complementary trigonometric ratios. Now, had it been tan here, then another one would have been cot, because tan and cot are complementary trigonometric ratios. And had it been sec in this place, it would have been cosec here, because sec and cosec are complementary trigonometric ratios. So that is how the questions will be asked as we will proceed. You will find the questions like that. Sine and cos together, tan and cot together, sec and cosec together. Let us solve. How to solve? Let us see. Now we know the sum of the angles here is 90. 18 plus 72 is 90 degrees. To use this relation, one of these relations, we would like to transpose one of these angles to the other side. Now the choice is yours. You may transpose 18 or 72. Choice is yours. I shall now make a scheme here. We will be following transposing of smaller angle to the other side. In this sum, whichever will be smaller, will be transposing that. We'll be using that procedure. Though we can transpose the other one also. So as we transpose 18, we will get 72 degrees is equal to 90 degrees minus 18 degrees. 18 I transpose. Then the acute angle that we isolated, 72. In the question we will find with that 72 degree which trigonometric ratio is involved. 72 involves cos. So to make this cos 72, we'll not write cos on one side only, we'll have to introduce it on both sides. Therefore you write introducing cos to both sides. We get left hand side will now be cos 72 is equal to right hand side will become cos of 90 minus 18. We have introduced cos, and remember you have to introduce it on both sides. If you recollect, in the previous class, in the chapter logarithms, we introduced log in some questions, and that log was introduced on both sides. Likewise here we have to introduce cos, and it will be introduced on both sides. You cannot introduce on one side, other side will not introduce. Or you cannot introduce cos on one side, sine on the other side, tan on the other side. No, you have to introduce same trigonometric ratio on both sides. And then on the right hand side, now you have the application of this relation. We have cos 90 minus 18. This is similar to what we have here, cos 90 minus theta. Instead of theta, we have 18 here. This second relation you have, cos 90 minus theta, equal to sine theta. Now in this relation, if you replace theta by 18, what will this become? Cos 90 minus 18 is equal to sine 18. And that is what you have to use here. Cos 90 minus 18 is therefore sine 18. This will become therefore cos of 72 degrees is equal to sine of 18 degrees. We have used the relation, write that as reason because cos 90 minus theta is equal to sine theta. Now what did we do in this relation? We replaced theta by 18 because that 18 is in place of theta here. 90 minus theta is not there, it is 90 minus 18 there. So instead of theta we have 18. Cos 90 minus theta is sine theta. So we replaced theta by 18, we got cos 72 equal to sine 18. And finally, this result that we got will use in the question right now. The question we have is sine 18 degrees divided by cos 72 degrees. Value of this we have to find. And to find that, now use for either cos 72 sin 18 or for sin 18 cos 72, because those are equal. If we write for sin 18 cos 72, this will become cos 72 degree by cos 72 degree. Numerator and denominator being same will cancel. The result will be 1. So the answer for this part is 1. I have explained this in detail here in this part. In the coming parts, the same procedure will be applied. Now this many details will not be there. I shall quickly go through again. I have two angles 18 and 72. Their sum is 90. I have written that. Then the smaller one I transposed. I said we can transpose larger also, but I preferred smaller one. Choice is yours. Then the angle which we isolated 72 had in the question cos with it. Therefore, this cos we introduced on both sides. Left hand side becomes cos 72 is equal to right hand side becomes cos 90 minus 18. And then comes the application of these relations. How will we identify out of 6 relations which one we have to use? It is cos 90 minus 18 means cos 90 minus theta relation you have to use. Cos 90 minus theta is sin theta, and in this when we replace theta by 18 it will become cos 90 minus 18 that we have here equal to sin 18. Therefore, instead of this I used sin 18. And finally, this result I used in the question. Now, let us solve the second part of this. Second part. The second part of this is tan 26 degrees divided by cot 64 degrees. This is the second part. Here also you can find angles are not specific angles, but their sum is 90. And with these we have trigonometric ratios tan and cot, which have complementary relation. Tan and cot are related by complementary angles relations. How will we proceed? Sum of these angles will again take 26 degree plus 64 degree is equal to 90 degree. And then transpose one of these. I said we'll be transposing smaller angles. So 26 will transpose. This will give us 64 degrees is equal to 90 minus 26 degrees. And then at this stage we introduce a trigonometric ratio. Previously we introduced cos on both sides. Because there 72 had cos with it in the question. This time you have 64. You have to find which trigonometric ratio is with 64 there. It is cot. So you have to introduce cot on both sides. Introducing cot on both sides. We get cot 64 degrees is equal to cot 90 minus 26. Cot 64 is equal to cot 90 minus 26. And here again the right hand side takes the shape of these relations, and you can identify which relation out of those 6 will be used. It is cot 90 minus theta. Cot 90 minus theta is equal to tan theta. So this relation you have to use. And in this relation you have to use 26 for theta. It is cot 90 minus 26 is equal to tan 26 therefore. Therefore, cot 64 degrees remains as it is equal to, here when you use the relation, it is tan 26 degrees. The result we got from this table, cot 90 minus theta is equal to tan theta. Then we use this result in the given question to get the answer. Now, tan 26 degrees divided by cot 64 degrees is equal to. For tan 26, we'll write cot 64 because these are equal. Divided also by cot 64. And these will then cancel. The result will be 1. Here also the result is 1, like previous part. And then you remember, such questions are asked generally as multiple choice questions. Whenever you have division of this type, angles are complementary angles, trigonometric ratios are complementary trigonometric ratios, then the result always will be 1, as you have seen in case of first part also. And we can have a question involving sec and cosec also in the same way. Sec in numerator, cosec in denominator. Again, result will be 1, provided the angles will be complementary angles. Now, part number 3. In first and second parts, we had to divide the 2. Now you have the difference of 2. Part number 3, we have cos 48 degrees minus sin 42 degrees. Operational sign has changed. Instead of division, it is minus now. But the procedure will be same. And the result this time will not be 1 because it is not division here, it is subtraction here. Let us see in case of subtraction what will be the answer. So the angles again are complementary angles. 48 degree plus 42 degree is 90 degree. Transpose the smaller one as per the scheme. 48 degrees will become 90 minus 42. And then which trigonometric ratio will be introduced? The one which is with 48. 48 of cos. So introducing cos. Introduce cos to both sides. We get cos 48 degrees is equal to cos of 90 minus 42 degrees. And then use the relation from this table. Again it is cos 90 minus theta that you have to use, equal to sin theta. And this time theta is 42, 90 minus 42, 90 minus theta. In place of theta we have 42. Means you have to replace theta by 42 this time. Cos 90 minus 42 is then sin 42. So we have cos 48 degrees is equal to sin 42 degrees. The reason will again be that relation. Cos 90 minus theta, you can write here, is equal to sin theta. And then to get the answer finally, we'll use this result in the question. So now, cos 48 degrees minus sin 42 degrees will be equal to, instead of cos 48, we'll write sin 42. It becomes sin 42 degree minus sin 42 degree. Both being same will again cancel, but this time it is minus, because of which it has cancelled. Previously it was division. And in case of subtraction, the result will not be 1, it will be 0. 8 minus 8 is 0. Sin 42 minus sin 42 is 0. So the answer here is 0 therefore. Previously it was 1. And same answer you will get for fourth part also. The trigonometric ratios involved there are cosec and sec. Angles are 31 and 59. Sum is 90 again. The procedure will be same. I would like you to do that part yourselves. Forward to second question. Question number 2 has again 2 parts, and we are asked to show something. Means you have to prove LHS equal to RHS. The first part here is tan 48 degree multiplied by tan 23 degree multiplied by again tan 42 degree, then again multiplied by tan 67 degrees is equal to 1. We have to show this. Means you have to prove this result. And whenever you have the questions involving prove that, show that, we show left hand side is equal to right hand side. So what will we shall do? We will consider its LHS and simplify that. LHS here is tan 48 multiplied by tan 23 multiplied by tan 42 multiplied by tan 67 degrees. We will show this is equal to 1. This time you have 4 angles involved, 48, 23, 42, 67. And all of them have the same trigonometric ratio tan. To solve this question, you will find out of those 4 acute angles, which 2 are complementary. You will have 2 pairs of complementary angles involved. 48 and 42 are complementary angles, their sum is 90. 23 and 67 also are complementary angles, their sum also is 90. Now these pairs we will handle separately, use the procedure we learned in the previous question, and finally get the answer. So let us consider first the pair 48 and 42. Sum is 90. We'll transpose the smaller one. 48 degrees will be then equal to 90 degree minus 42 degrees. So same procedure I am using. Then which trigonometric ratio will be introduced? It will be the one with 48, the angle which we have isolated, separated. We transpose 42, that one you need not use. The one which have 48 with 48, and here all are tan, so therefore it does not make any difference. In the previous part you have seen it makes the difference. You have to use the trigonometric ratio with 48, it is tan, so introduce tan to both sides. Introduce tan to both sides. We have tan 48 degrees is equal to tan 90 minus 42 degrees. And then at this stage we use the complementary relation. You have the table there. You have to identify which one. It is that of tan. Tan 90 minus theta is equal to cot theta. This relation you have to use. And in that, theta we have to replace by 42. It will become therefore tan 90 minus 42 is equal to cot 42. Thus it is cot 42. Tan 48 degrees is therefore equal to cot 42 degrees. Then second pair of angles that we have, 23 and 67. Their sum also is 90. Now the same procedure will apply here also. You will transpose 23. That will become minus. And on the basis of 67, then decide which trigonometric ratio will be taken. It is again tan here. So introducing tan again, you will get another result. And the result will be tan 67 degrees is equal to cot 23 degrees. Those steps which I have left here, you will do accordingly. Procedure will be same. Having done this, now we'll use these in the question. So right now, question is tan 48 degrees multiplied by tan 23 degrees multiplied by tan 42 degrees multiplied by tan 67 degrees is equal to. We'll use in this given LHS the results we have just now proved. Tan 48 we have cot 42, so we'll replace tan 48 by cot 42 here. It will be cot 42 here multiplied by. Then we also have tan 67 equal to cot 23. So cot 23 is tan 67. We'll write for tan 67, we'll write cot 23. But that is here, tan 67, which we have to replace by cot 23. These two trigonometric ratios will keep same. Tan 23 degrees multiplied by tan 42 degrees Then instead of tan 67, you have cot 23 degrees. We used the values we just now proved. And then this will further become, you have earlier read, cot and tan are reciprocals of each other. We discussed that in the first exercise. Cot and tan are reciprocals. So wherever you got cot, you can change it to tan by writing the reciprocal. Cot 42 will then be 1 by tan 42. Cot is reciprocal of tan. So cot 42, I have written 1 by tan 42. Multiplied by, I don't have space enough there, I shall write here. So cot 42 I shall replace by 1 by tan 42 being reciprocal, multiplied by tan 23 will be same, multiplied by again tan 42 will be same, and then multiplied by, instead of tan 67 we have to write 1 by cot. We have cot 23 which will be reciprocal 1 by tan 23. Reciprocal of cot is tan. So at two places that reciprocal relation I used. Here for cot I used 1 by tan. Here also for cot I used 1 by tan. Here the angle was 42 degrees, so it is tan 42. Here angle is 23, so it is tan 23. Now this tan 42 will cancel with tan 42. Tan 23 will cancel with tan 23. The result is 1, which is the right hand side of this question. That proves our first part of this question. I don't have time sufficient now to do the next part. Let us conclude the day here.